Hey guys, today's lesson is 1.6 Inverses Algebraically. So on 1.5 we looked at how to find inverses on a table or a graph, but now we're going to look at how to find an inverse only looking at equations. So go ahead and write that down and then turn to your notes page. So just like whenever we try to find an inverse in a graph or a table, we would switch the x and y coordinates. We're going to do the same thing with an equation. So here's my original function, y equals 1/2 x plus 3, and let's go ahead and graph it. Remember to graph on your calculator, you have to pull up a new document and then add graph, and then you would type this in. So you could graph it on your calculator, or you could just do it by hand if you remember how to graph equations by hand. Your y-intercept would be 3, and then your slope is 1/2. So we would have a rise of 1 and a run of 2. So it'd go up 1/2. So anyways, it should look something like this. And we're going to call this f of x because it's our original function. Remember that I could also write this as f of x equals 1/2 x plus 3. F of x and y are the same thing. Okay, so now what we want to do is find the inverse equation for this function. So you could pull up your table or look at your coordinates and then just switch them. Remember, switch the x and the y's. But we actually want to find an equation to represent the inverse. So what we're going to do is we're going to switch the x and y on the equation. So this would become x equals 1/2 y plus 3. See, I just switched the x and the y. And then we're just going to solve for y. Because remember, in order to graph an equation, you have to get y by itself. So if I want to solve for y, I need to subtract 3 from each side. So I would have x minus 3 equals 1/2 y. And then I would need to either divide by 1/2, or the easiest thing would be multiply by 2 on each side. But be careful here. Whenever you multiply this left side by 2, you have to multiply the entire equation by 2. So we need to make sure we put the x minus 3 in parentheses. So I would be left with y equals 2 times x minus 3. And if you wanted to, you could distribute it out, so you would end up with 2x minus 6. Alright, so let's go ahead and graph this inverse function. So I would start at -6 on the y-axis, and then my slope would be +2. So I'd go up 2/1, up 2/1. And remember, if you needed to graph that on the calculator, you could, if you need help on knowing what that graph would look like. So as you can see that these are inverses, they reflect on this line y equals x, which is right here. And then it asks, is the inverse a function? So let's go ahead and notate this inverse graph as f to the -1 of x to show that that's the inverse. And would this pass the vertical line test? Yes, it would. Alright, so moving on, now let's go to the next one. So now my original function is y equals x squared. So if you need to, you could type this in the calculator, or we could just plug in some values for x and square it. So let's start with 0. 0 squared is 0. 1 squared is 1, so I'd have a point at 1, 1. 2 squared is 4, and then 3 squared is 9. I could also do the other side. Negative 1 squared is positive 1. Negative 2 squared is positive 4. And then negative 3 squared is positive 9. So we would get this quadratic shaped graph. And let's label that as f of x since my original function. Alright, so now we're going to find the inverse function that would represent this graph. So same thing, we need to switch the x and the y in the equation. So this would become x equals y squared. And then we need to solve for y. So I'm going to take the square root of each side to get y by itself. And that would leave me with y equals the square root of x. But remember, whenever you take the square root of something, you can get a positive or a negative answer. Because let's think about it. If I took the square root of 25, I could have 5 or negative 5 as my answer. Because if I square both of them, 5 squared is 25 and negative 5 squared is also 25. So anytime you take the square root of something, we need to start getting in the habit of writing plus or minus on the outside of it. So now let's go ahead and graph this inverse function. So if I were to graph this on the calculator, for one of my graphs, I could type in y equals positive square root of x. And then on the other one, I could do y equals negative square root of x. And so we would end up with the graph. Let's start off with the positive one. So if I took like the square root of 4, I would get 2. And then the square root of 9, I would get 3. So it would look something like this. And then I would do the negative version of that as well. So I would just copy it across this x-axis. I would have a point at 4, negative 2. And then 9, negative 3. And if you need to take some time and make sure that you type this in your calculator correctly to get that whole graph, you can do that. So now we can see that both of these functions are reflected across the y equals x line. And then let's go ahead and label this red one the inverse, so it'd be f to the negative 1 of x. But then it says, is the inverse a function? So is this red graph a function? Would it pass the vertical line test? And no, it would not, because if I took a vertical line and went and drew it straight down, it would pass at more than one x value. So this inverse is not a function. And I'm just going to abbreviate VLT for vertical line test. Alright, so how could we restrict the domain of the original function to make it invertible? So basically what we want to do is, starting off with this blue function, this blue quadratic graph, we want to restrict the domain so that the inverse would be a function. And what we would have to do is get rid of this negative section, because, let me use this yellow again, this section right here is what we would need to get rid of on both of the graphs in order for this graph to be a function. So basically what we need to do is just restrict it to positive values. And so if we're restricting it to positive values, remember domain is all of your x values, so we would have to say x could be greater than or equal to 0. So whenever we inverted it, let me just draw a little picture here. If we got rid of the left side of the quadratic graph it would look something like this. I would only have the right side of that quadratic, only the positive x values. And then whenever we inverted it, it would look like this. So now it would become a function. Alright, moving on to the next page. Originally, I had a second page of notes for you, but I made a typo on them, and also they just didn't give you very good examples of the IXL that you're about to do. So anyways, I'm going to show you some of the IXL examples. If you want to follow along on some scratch paper, you can, or you can just watch. It's whatever you prefer. So here's an example of one of the IXL questions. It says the graph below shows a function. Is its inverse also a function? So what you could do is, on this graph, since it's linear, whenever you invert a linear equation, you know it's going to be a function. But if you wanted, you could plot a few points. Like, here's one at 2, -2, and 0, -4. So if I switch those, remember you could just switch the x and the y. So 2, -2 would become -2, +2. And then 0, -4 would become -4, 0. So you would get something that looks like this. And you can tell that it would reflect across this line, y = x, and it is a function. So you just hit yes. So anyways, on those questions, you're just going to hit yes or no if the inverse would be a function. Also, if the inverse, or if the original, so this purple line, passes the vertical line test and the horizontal line test, that means that its inverse would be a function. So let me show you what I mean by that. So this is the original graph, and it does pass the horizontal line test, or the vertical line test. And if I drew a horizontal line, it also would pass it because it would only go through one point. Remember, because if you invert a horizontal line, it's going to become vertical. So if it doesn't pass the horizontal line test, whenever you invert it, it's not going to pass the vertical line test. Here's another example. Find the inverse of the function y = x - 2. So this is exactly what we were doing in our notes. I need to switch the x and the y to find the inverse equation. So I would have x equals y - 2 after I switch them. And then I need to solve for y. So I would just add 2 to each side. So I would get x + 2 = y. So that would be what you would type into the box, is x + 2. And just think about it. Isn't the inverse of subtracting 2 adding 2? Okay, next example. This one says find the inverse of the function. So same thing, I need to switch the x and the y. So I would get x equals the cube root of y, and then -2 would be on the outside of that radical. So my first step would be to add 2 to each side. So I would get x + 2 equals the cube root of y. And then, since I'm taking the cube root of y, in order to get y by itself, I would need to cube each side. So I'd be left with x + 2 cubed equals y. So I would type in x + 2 in parentheses and then cube it on the outside. Okay, last example. This one's a little bit harder because it's going to be one of those parabola ones where we have to restrict the domain. And as you can tell, this is probably going to be in like the 80 range on your IXL problems. So we need to find the inverse of the function. So once again, switch the x and the y. Okay, I need to get rid of this radical. So the inverse of taking the square root would be to square each side. So I would get x squared equals y - 6. And then I need to add 6 to each side. So that would leave me with x squared plus 6 equals y. So I would type that in the y equals part. But then we need to think about how it would restrict my domain. One of the easier ways to think about this is to graph both of these equations. So let me sketch what that would look like. So my original square root of x minus 6 would be out here, and it would start at positive 6 on the x-axis. And then my inverse would be up here at the very top at positive 6 on the y-axis. So for these two to be inverses, we need them to have that symmetry across this line y equals x. So I need to get rid of this negative part of the parabola. So I need to restrict my x's to only be on the positive side. So on the inverse, I need to say that my x's need to be greater than or equal to 0 so that I only get the positive side of this graph. So I would say greater than or equal to 0. And on the IXL, you can actually select this greater than or equal to sign. Alright, if y'all have any questions on this, let me know. Hope you guys have a great day. Bye.